Right, morning. So you want to take a look at integration, right? We're going to just do a quick review on integration, and then we're going to start applications of integration, right? How do we integrate? Add 1 to the power and divide by the new power. And we always include the variable c, constant c, right? So this will simplify to 5 over 4 x to the power of 4 plus c. Please remember, once you have constants, you can pull the constant outside of the integral sign. That's okay? So these two are the same thing, right? If I ask you to integrate, let's say, 5. What's the integral of 5? Right? The integral of 5 is simply 5x plus c. Okay? If we are to integrate something like this, 2x squared plus 4x minus 3 dot dx, we treat them individually. We integrate each one individually, right? So we integrate 2x squared first. We add 1 to the power. We'll get 3. Divide by that new power, which is 3. Plus 4x, add 1 to the power. You'll get 2. Divide by that new power, which is 2. Minus the integral of 3 is 3x. And then you add your plus c. That's okay? All these are examples of what type of integrals? Indefinite integrals, right? Right? Let's do a couple examples of what indefinite. Actually, let's squeeze it in right here, right? Suppose I said I wanted the integral of 5 between the limits of 3 and 1, right? What you do is just ignore the constant and you plug in the 3 and then you plug in the 1 and minus the values, right? So it will be 5 by 3 minus 5 by 1, right? Which is 15 minus 5 and 10, right? That's basically how you handle definite integrals. Okay, let's take a look at the other types of integrals that we need to know. Right, remember I told you you can put this in the calculator and just check your answer, right? Once you have a definite integral, right? Once you have a definite integral, go to the calculator and check the value just to make sure you get it. All right. We need to also be able to integrate functions like this: 5x minus 1 to the power of 3. Right? How do we integrate things like this? Add 1 to the power, divide by the new power, and divide by the differential inside the bracket. Right? What's the differential of 5x minus 1? 5. And then you add c. Right? If you have to integrate the square root of 2x minus 1, try that fast. Try that quickly. Yeah? Try the square root. Saturdays will stop the last Saturday in this month, right? That'll be the last Saturday. And then it's crash course, and then I want to do individual work after that. If you want to come and do individual work, you can come on. Right, so this is really the integral of square root means to the power of a half, right? I have to fix it quick. right? So you should have something like this. Add 1 to the power, you'll get 3 on 2. Divide by that new power, which is 3 on 2, and divide by the differential of 2x minus 1, which is 2. Right? These two will cancel. So you'll be left with 2x minus 1 to the 3 on 2 all over 3. Right? One thing I told you, if they give you something in a square root, try to give them back in a square root, right? What does 3 on 2 mean? 3 on 2 implies 2x minus 1 cube, right? 3x minus 1 cube, square root of all of that. Right? Remember that 3 on 2 means 3 by a half. Right? All over 3, which is 1/3. Okay, so 3 over 2 really means cubed, and you can square root the whole thing. Right? It means cube by a half, right? Sorry, that's 2. That's 3 underneath. I just bring it up from third into a fraction. 1 over 3. This one here. Yeah. Change this board. I want to go back on the board, but I want to change it because I find it looking too dark online. Yeah. Yeah, but here's the 30, so that's why I selected the screen fully white. I have a new board down, so I want to switch it. Right, we have to be able to integrate what again? Oh, some of you all get this one wrong. How you'll integrate something like this? How you'll integrate something like this? There's no quotient rule for integration, right? You can't put x outside. You're going to put constants outside. What else you can do? What is it? I keep it this on the worksheet. You're looking back in the work. Anybody remember online? Chevelle? It must be able to simplify, right? Or we could simplify something like this. All right, yeah. You can carry x to the 4 on top. Now you might be able to factorize that. So what you could do is this. You can divide each of the terms on top by x to the 4. Right? And then simplify that out. Okay? You can divide each of the terms by x to the 4 and then simplify it out. So you'll get 5x to the minus 2, right? Same base, you divide in your subtract powers, right? Here you will get 3x to the minus 3. Here you will get 2x to the minus 4. Please some more than watch the video, you know. I did the same thing in the video. Integration. You have an integration. Right, add 1 and then integrate it now from a plus. Right, so add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by that new power. And that's it. You'll get minus 5x to the minus 1 minus 3 and 2 x to the minus 2 minus 2/3 x to the minus 3 plus c. Right? But write it back as a fraction, right? So your final line will be minus 5 over x minus 3 over 2x squared minus 2 over 3x cubed plus c. Right? Just in case you're not seeing it, this is 2/3 by 1 on x cubed, right? And when you multiply it, you'll get 2 over 3x cubed. Why it's not? Huh? Because minus 5x to the minus 1 means minus 5 by 1 over x. When you multiply the minus 5 by the 1 over x, you'll get minus 5 on x, right? Generally with square roots here, right? Generally with square roots. Right, last thing, integral of trigs. Last thing is integral of trigs, right? So you have to, if you have to integrate cos x, what you'll get? Integral of cos is what? Sine. And the integral of sine is what? Right, minus cos. But if you have to integrate, let's say cos 2x, how is integrate something like that? One over, right? 1 over the different. 1 over the differential of 2x, which is 2, right? So you have to differentiate this 2x and put 1 over that. And then you start back the integration. The integral of cos is sine, then you write back 2x. Try the next one. What about if you had 4 sine 3x? What do you do with the 4? Put the 4 on the outside, right? And then integrate. Go ahead, try it quick. Everybody else online there besides Dimitri. Only Dimitri sent anything. Ryan, you there? Shania? Yeah, okay. Integrate 4 sine 3x, right? If you want, you could take the 4 and you could put the 4 on the outside. Pass up all the ADMAP solutions. Most of them, but I can survive with that. It have nothing to do with physics and have nothing to do with physics and thing, right? No, like generally, have any physics solutions on it. Solutions online for free. Who website is that? Or there's post-diesel PDFs with solutions in it. Okay. When you're looking at these solutions, you either look at a video on the solutions or just read the solutions. the answer. Now, I mean, like myself, yeah. So look at that video for the solution. Right, so let's check this out. So it will be 4 by 1 over the differential of 3x, that's 3. The differential of sine is minus, so I put in the minus here, minus cos, and then you write back 3x. So your final answer is minus 4 and 3 cos 3x plus c. Yeah. Right, so yeah. Wait a minute, you want to multiply the 4 by the c2? No, you can leave it right there. Leave it right there, add the c. Right, so good. Let me just give you one more with this, right? Suppose I gave you something like this, pi on 2 and 0. Find the integral between 2 sine 4x. Try that fast, message your answer. And then let's go to the applications, right? And work out this one, please. Yeah, any answers? Message your answers so on to get. Also, you can check it in a calculator, right? If you have a calculator. Anybody missing a calculator, like the velocity? You just have to cast your calculator. Integrate that quick, plug in the values, let's see what you get. Do it by the calculator as well, right? Right, do it by the calculator as well. Right, let's check your values. And values online. I have two values, or do I have no values? I have two, I have 0, and anybody gets 0 again? 0, I have 2 zeros. Let's see. Right. So first thing first, right? First thing first, we integrate, sorry, is 1 over the differential of 4x, which is 4. The integral of sine is minus cos, right? When you're writing the minus, don't put it in front of the cos. It looks like this value minus this value, right? It's just a negative sign, not a subtract, right? The integral of sine is minus cos, and then you write back the 4x, right? So now we have negative 2 over 4 is a negative a half, right? Between pi on 2 and 0 of cos 4x. I left the negative half outside, so I don't have to include it, right? But nothing wrong if you include it. So you find cos 4 of pi on 2 minus cos 4 of 0, which is, what is that? What's this here? This is 4, 2, that cos 2 pi is 1. Huh? Are you working in radians, right? Cos 2 pi is now 1. Check and see. Cos 2 pi is 1, and cos 0 is 1. 1 minus 1 is 0, so your final answer is 0. Right? But you'll get inside there wrong if you write cos 2 pi is 0, right? Check and make sure. Or 4 in front, right? So cos 2 pi is 1. Check in the calculator. Just make sure again, all right? Cos 2 pi is 1, and then cos 0 is 1. And then 1 minus 1 is 0, right? Are you okay with that? Are you okay with that? All right, so now we want to take a look at the applications of integration, right? So we did a small summary on integration. Let's take a look at the application. We have 3 main applications at this level for integration, right? The first application is if I give you dy dx. The first application is if I give you dy dx and integrate it, you'll get back the original curve or the original function. All right, so the integral of dy dx is y. Also, if you integrate between limits b and a of any function, what you're really doing is finding the area underneath that function. So if they ask you to find area, all you need is the function and the limits between where you want to find the area. Are you okay with that? That's the first application. Second application, and the last application is to find volume. If I ask you to find the volume when I rotate this function 360 degrees, right, you will get some kind of shape. The volume of that shape is pi between the limits of y squared. So for example, if the function is equal to, let's say, the square root of x, then you have to integrate pi between the limits of square root of x squared, right? Do not forget that. You have to integrate between the square root of x squared. Look at that. Let's make a note of those three things. And let's take a look at some applications, right? So once you see volume, using this formula here. Once you see area, you're using this formula here, right? If you see find the equation and curve, you integrate dy dx. So those are your three applications. There's one more that we'll do next week. The last application is what? Kinematics, right? The last application, kinematics, what we did Monday. Yeah, remember that? Or just remember to share paper in the group now and try and do a full paper Monday. That'll be my end of my exam. Nobody here. Oh shucks, Jimmy online. Right, so those are your three applications. Right, sometimes they don't give you your limits and you have to figure it out, right? Well, you have guidelines. Well, again, a full paper, right? So I know guidelines there, do a full paper. He didn't finish. Well, again, you're in trouble. I never hear enough finish. You are? Less, okay.
What would be?
Yeah, like it, plug it in and see.
Oh, yeah.
Ready? So those are your three applications, right? All right, ready? Everybody writing? Right, let's take a look at the first application here. Right, you will have to decide which one we're using here, right? Right, let's just try one quick easy one here. I given you a function. Let's say the function here is 2x cubed minus 3x, right? I would like you to find the area between 1 and 2. Try that, please. Find the area between 1 and 2. Take your time, right? Find the area is basically integrating between 2 and 1. Take your time and integrate it. Yeah, after you integrate, that's Any answers?
Yes,
Sure. All right, let's check this out. Hold on, I just get disconnected again. All right, so let's see. So the area is equal to the integral between 2 and 1 of 2x cubed minus 3x dot dx, right? So when you integrate this, you'll get 2x to the 4 over 4, 3x squared over, right? So you'll end up with 2 to the 4 on 4 minus 2 squared on 2, right? And then you minus them with 1, right? So that'll be 2 by 1 to the 4th on 4 minus 3 on 2, right? How much is that? Two, which is 3, right? 3 in the end. Okay, nice. So you got 3 units, right? Right, so in the end, you will get 3. Next one. Try this next one here. Oh wait, I lost the paper. Try this next one here. Determine the area bounded by the regions. Determine the area bounded by the regions. Sorry, determine the area of the region bounded by the curve. Determine the area of the region bounded by the curve. I'll write a curve here, right? The curve is y is equal to 5 plus 5x minus x squared. So it's bounded by the curve y is equal to 5 plus 5x minus x squared, comma, the x-axis, the y-axis, and the line x is equal to 2. The x-axis, the y-axis, and the line x is equal to 2. So once you see all those words, there's some confusion, right? X is equal to 2. Call it over, right? Determine the area. Determine the area of the region bounded by the curve y is equal to 5 plus 5x minus x squared. The x-axis, the y-axis, and the line x is equal to 2. So we had to figure out what they're asking for there, right? It's something complicated, but it was simple. What do you think we have to do there? They ask for area, right? So therefore you have to what? Integrate between what? We need the limits, right? 2 and 0, you think? All right, let's see. Right, so 5 plus 5x minus x squared might look something like that, right? It don't matter how it looks, right? But here's what you're looking at. You're looking at the boundary of the y-axis, boundary of the x-axis, and the line x is equal to 2. So it means that they want the area trapped in here. Okay, so it means that your boundaries are 2 and 0. Right, so very good. Right, so to find the area, you're integrating between 2 and 0, this function here. Right, very good. Integrate it from a place. Integrate between 2 and 0, 5 plus 5x minus x squared. Right, work it out, yeah, and then you can check it in the calculator, but work it out first. Finish? Get the values. All get? What you got? Yeah, just break it down for me now. Most people get 17.3, 17 and a third. Okay, nice. Let's check it out and see. So we have to integrate, right? So once you integrate, take off the integral sign, and then you plug in the 2 and the, you have to integrate, then plug in 2 and 0, right? The integral of 5 is 5x. The integral of 5x squared, 5x is 5x squared on 2. The integral of x squared is x cubed on 3, right? Then you plug in the 2, right? And then you plug in the 0, right? You'll just get 0 there, right? So this is what? This is 10 plus, this is 2, right? 10 plus 10 minus what? 8 on 3. So that is 17 and 2 units. Units, so I can put units squared. Good. Nice. Let's try the next one. Ready? Ready? Right, so I'll give you the important stuff. Oh, that was 2022, eh? That was our actual past paper. This is 2020, this is 2012. Calculate the volume. Actually, hold on, eh? Let me share this because I want to do this entire question. This is 2012. I'm gonna just send this whole thing in. Taking this off, right? Let's take a look at this here. This is 2012, right? It's a full question on everything. Full integration question here, right? Let's see if we can do the whole thing. Start from D though. Start from D and then go up. Start from part D. This is 2012, right? And you can leave your answer in terms of pi. So when they say volume, what's the formula we're using? When they say volume, pi by the integral between the limits of, right? And then you square in the y, right? So if this is your y, this is your y, you have to square that. Okay? You have to square that in your formula, right? Okay, go ahead. Integrate it. Let's see what you get. Just seeing you there. Go ahead. Take your time to part D, then see. Let's see already. But I want to do B and anybody have it? Possible, okay? Right, so remember you have to square it, right? And by starting integrate, let's see how you square it up. Okay, then after you, or you can use this technique plus one. Up to you. So you have this, and you have this, right? And then you're gonna plug it here. Right. Leave the answer into the pi, right? But you're not expanded. Anybody integrate already? What else we did in that order? We start from B. Well, put brackets here at minus 0, right? We should write something to the bracket. But I have to do it. Yeah. Right. Right. Now you're like, you just keep reading on it. They don't take all mark for that as level, but I want to follow. I want to follow. Bring up the follow. And it's square. It's square. Right, let's check out some answers. Have any answers online here? Right, leave it in terms of pi, right? I will leave mine in terms of pi as well. Once you finish, move on. Now, Dimitri, you finished A, B, and C and D already? What? So starting with the volume, right? So that will be pi by, right, 30x squared plus 2 squared. So before I start to integrate it, I am going to expand it out, right? So that will be x to the 4th plus 4x squared plus 4 dot dx. Dimitri, you have to show the working, huh? Right? And then you'll get pi between 3 and 0. Add 1 to the power, divide by the new power, add 1 to the power, divide by it, plus 4x. Right? Then you're going to plug in your 3 and then you're going to plug in your 0. Right? So when you plug in your 3, you'll get 3 to the 5 over 5 plus 4 by 3 to the 3 over 3 plus 4 to the 3. You still have to write this by the integral of 0, right? When you plug in 0, you'll get 0 on that side. So Amanda got 4, 8, 3, and 5 pi. Right? Units, because it's volume, you can write units cubed. Well, look at that, 4, 8, 3, and 5. Check and see. Just put back that part in the calculator. But when you had all of that, you have all of that. You just have 4x, 2x cubed plus 2x cubed on 3. You have that same thing. I just watched it in your book. 4, 8, 3 on 5, 5. So consider. Try and work over the part in brackets and just make sure you get out, right? You got out? Plug the value in and see now. 3 to the 5 on 5 plus 4. Right? In by pi, right? 483 on 5 by pi. Okay, nice. So correct? You get that, Shana? What you do? You're supposed to get the same thing even with your method. I'll check it as now for you, right? But you left the pi on the outside. Right, next, let's take a look at B, right? We'll do C just now. I want to make sure we do B before time around. Right, most important thing, just put a little star here, please. The most important thing is that you don't forget to square this, right? Don't forget to square it when you're working out volume. Right, let's try part B now. Look at part B. The point P, which is 4, 8, lies on the curve, and they gave you dy dx. How are you going to get the equation, Arya? How are you going to get the equation if they give you dy dx? Integrate it. But you have a problem. When you integrate something, you're going to get a what? You're not going to get the full equation plus c. How you get rid of plus c? Substitute the points 4 and 8 into the equation, right? That'll help you find c. Try it fast. Try part B quickly. Ishana, I'm gonna see yours. Are you integrated that quick? Right. Right. Back we will always.
Take a few minutes. Want to with me? Right?
Yeah, cool. I can see it. Yeah, change as much as I can change. As much as you can change in 9, so go ahead now. Right? Do that. Right, so let's see. Let's see what you got. Question said that dy dx is equal to 3x minus 5, and the point they gave you is 4/8. Right? So therefore, we're going to integrate 3x minus 5, right, to get y. So y is equal to 3x squared over 2 minus 5x plus c, right? That's not enough. We still need to get c to get the full equation, right? So when x is 4, y is 8. So 8 is equal to 3 over 2 by 4 squared. Come on. Huh? Again, 9. All right. So 5 out of 4. So 3 on 2 by 4 squared minus 5 on 4 plus c. How much you got for c? 4. So your final equation is y is equal to 3 on 2x squared minus 5x plus 4. Right? So you just integrate and you get the equation. But remember to do stuff here, you still have to get c. Copy it down. Let's do the last one and we're done, right? 2 part c. Copy down quick. Although you get 9s, when you round it up, it just end up getting 10. It end up with 12. Sometimes a 9 do affect it. Because if you get 9, if you get a 10 and 10 and 9, and you add it up and you get 0.5, they'll round it up in the next. You'll do a math and a hard math project, but that's math. Not math. Make my chair and do the other way around. All right, next one, last one here, right? No. Yeah, the message I'm saying. Yeah, he didn't message him, tell him.
I think he did. I told him.
All right, hello, come. Last one, C. Work out C, please. Find the area between 0 and pi on 3. Right, that's now you'll see. Sometimes these questions is why to work in surds, right? Yeah, so sometimes the answer will be in surds. Last one is C, right? You can do A fast. Anybody do A? Those who finish C go on to E, go on to A real fast. I'll just tell you what the answer is. Dimitri got 233.75. E. Yeah, Hussein get that too. What do you get, Chevelle? 40.9. For this one? And you work in radians? I work in radians, right? So once you integrate here, you will get 2 sin x. Here you will get minus 3 cos x. Right? Then you have to plug in pi on 3. And then you have to plug in 0. Right? Pi on 3 is what? That's 60. So that's 2 by root 3 on 2 minus 3 by a half minus 0 minus 3. So that's root 3 minus 1.5 plus 3. How much is that? Well, you can leave your answer in suits and you will get 1.5 plus root 3. Close to like 3 points something. $3.23. Yeah, 3.23. Right, so say it's about 3.23, right? Okay, nice.